In section 5.1, we're going to talk about polynomial functions. So before we get into this section, there's some key terms that we'll want to go over before starting this. The first one is a monomial. A monomial is a real number, variable, or product of the two. So an example of this would be like 4x squared. Another thing that we usually say for monomial is just a term. So a term of an equation or an expression. The degree of a monomial is the exponent of that variable. So in that example for 4x squared, the degree of that monomial would be 2 because that variable is taken to the second power. And then from there, a polynomial is a monomial or sum of monomials. So a polynomial could be something like 2x cubed plus x minus 5. So here we have 3 different terms or 3 different monomials all put together, making this a polynomial. And the degree of a polynomial is going to be the greatest degree among its monomial terms. So in this example, our highest degree, there's 3, that 2x to the third power, so the degree of that polynomial would be 3. Here you can see the standard form of a polynomial function. This looks kind of weird. Write it down. You're not going to have to memorize this or anything, but basically what this is showing is that we are going to order in standard form for a polynomial. You want to order the greatest term to the least term. So again, arrange terms by degree in descending order. So for example, if I was given this equation, f of x equals 4 minus x to the fourth power plus x minus x squared, what I would want to do here to rewrite this in standard form is I'd want to arrange them in descending order. So I would write f of x equals negative x to the fourth power minus x squared plus x plus 4. So I didn't change the sign of anything here. All that I did was rearrange, so I put the x to the fourth power first, and then that x to the squared, and then x to the first power, and then that constant term at the end. The next important thing here for classifying polynomials is knowing the specific name for each degree and for how many terms there are. So going down the list here, if you have a polynomial of degree 0, or in other words, you just have a constant number, we call that a constant function. If the highest degree is 1, so all you see is x to the first power, just x, you call that linear, which we did at the beginning of this in this class. If you see something x squared, x to the second power, we call that a quadratic function. The new one that we're going to work with is if we see x to the third power, we call that a cubic function. Next, if you see something that has x to the fourth power, we call that a quartic function. And finally, if you see something taken to the fifth power, you would call that a quintic function. You could keep going here, but we're not going to work with anything greater than to the fifth power, in this class at least. The other thing that you're going to have to know when classifying polynomials is how to name them in number of terms they have. So as we talked about earlier, if a polynomial only has one term, we call that a monomial function. An example of that would be 3x squared. If that polynomial has 2 terms, we call that a binomial. And you can see the example to the right there. If it has 3 terms, we call it a trinomial. And then once you get to 4 terms, they just stop giving it special names. So if you have 4 terms, they would call that a polynomial of 4 terms. And if you had 5, you would say polynomial of 5 terms. So really, the main thing to know here is that 1 term monomial, 2 terms binomial, 3 terms trinomial are like the only fancy names. So kind of tying this all together, let's say we have this expression. I want to write this polynomial in standard form and classify it. So I'm going to want to name it. So what I'm going to do here is, as we talked about earlier, I want to order this in descending order. So I'm going to say f of x equals, I want to move that 9x squared to the front and leave that constant term on the end. And then from here, I need to think, what's the degree of this polynomial and how many terms does it have? Its degree here is 2. So the degree, sometimes we call that n, is 2. And how many terms does it have? 1, 2, 3. So we would properly call this a quadratic trinomial. Quadratic because the degree is 2, trinomial because we have 3 terms. So another important thing for understanding like the degree and everything in these polynomials is that the degree of a polynomial affects the shape of its graph by determining 2 things: the number of turning points and its end behavior. So we kind of talked about end behavior a little bit in the quadratics chapter, where if you had like a positive quadratic function, like you were going up for forever, like from 0 to infinity, stuff like that. Here with polynomial functions, there's going to be a couple different situations that'll happen. So this chart will be very, very important to write down. I would have this written down, highlight it, star it, depending on what your a value is. So the a value, again, is that leading coefficient for your that highest degree term, and then your n value is the degree itself. Depending on what your a value and n value are, that's going to affect the shape of the graph. So I'd write this down and highlight it. And what that means exactly is, looking at an example, I want to describe the end behavior of y equals negative x squared plus 2x. What I'm going to want to focus on is my a value and my n value, so the degree and my a value. Here, kind of tying into the last couple of chapters that we've done, my a value is -1. More importantly, my a value is negative. Further, my n value, or my degree, is 2. So it's even. In our chart, we saw that if our a is negative and our n value is even, that would relate to a down and down situation. And what that exactly means, if you graphed this, you would see that our graph is going to go something like this. So since going from the left or right of that graph, since both of these are going down for forever, that's what makes it a down and down situation. The last thing that we're going to talk about in this video is using differences to determine the degree of a polynomial function. So a question that you might see on a quiz or test would be, you're given a list of numbers, and I want to figure out what is the degree of the polynomial function that generates this table below. So here I see my x values kind of go in order. They're going up by 1 every time. But then my y values kind of seem all over the place. We go from -1 to -7 to -3, then to a positive number, then back to negative. So what I can do just by looking at this chart to figure out the degree is keep figuring out the differences until I get a constant difference between each term. So what I mean by that is my first step is I'm going to find the difference between all my y values. If this difference was constant or was the same, that would mean I have a linear function. Here I could see by these blue numbers that I'm not changing by the same amount every time, so I need to do this process again. So what I'm going to do now is find the difference of those numbers. Now, if those numbers were the same, that would mean that I had a quadratic function. Here I can see by that new list of red numbers that I have, I still don't have like the same difference every time. So this can't be a quadratic function. So I'm going to do the process again. Here I can see that moving from each number, I'm going down 6 every time. Since it took me 3 steps to do that, that means that my degree here is 3, meaning it's a cubic function, and in the end, the degree here is 3 of that function.